That's more than 2 years. 2.5 years ago, we started assembling the team and running our first experiments. Yesterday, many of us were in tears because we saw on stage what we had been waiting to see. And the robot was beautiful, truly beautiful. I suggest we dive a little into the backstage now. I'll show a couple of boring tables and a couple of cool videos. How we built the robot from the perspective of its physical embodiment and the non-inclined control systems. How did it all begin? From my point of view, it all started in 2022 when Musk presented his first Optimus prototype at a presentation, and when he set the trend, the hype trend. And many companies began investing specifically in anthropomorphic robotics. We did it too, although with a slight delay. At that time in 2022, the most dynamic robots were probably those from Boston Dynamics, which was still hydraulic back then, and of course the Optimus robot, which was just starting to take its first steps, but it attracted a lot of attention and hype. So what kind of robot do we want to build? We set ourselves the goal to make a powerful, agile, and very intelligent robot, so that all this artificial intelligence the guys talked about could eventually run on board. And of course reliable, because without reliability, robots often fall down. Our construction robots fall down. So let's say you decided to build a robot. What do you think you should start with? Well, you might think you should just start by picking out components and assembling robots. But if you do that, you won't find the components on AliExpress. Okay, no, not on AliExpress. Then you'll go to the websites of really cool companies that make actuators and electronics, and you won't find the components there either. And it turns out that the actuators we can buy are either too heavy or too unreliable, or they don't have the communication interface we need. And this applies to other components as well. It applies to processors, routers, and other electronics too. We struggled with this for a long time, and we spent a long time testing all the components on the market. It was difficult, but we achieved our goal. In particular, our team recently developed an optimization framework that uses dual-loop optimization. The lower loop handles locomotion. The upper loop deals with possible software actuators. Depending on the scenarios we specify in the requirements, the computational clusters work to suggest the optimal parameters for the actuators that need to be installed on the robot. That's actually really cool. Respect to Vanya Borisov's team. Custom electronics. Everyone thinks we just bought a Chinese robot. But look, we made all this electronics ourselves. All the electronics, because we didn't just want to make it ourselves. There simply wasn't any electronics available for sale that met our needs at all. Even if you take the router, it's unique. If you look at the power distribution system, it's unique too. And so on and so forth. Big respect to Vadim Bolshikov's team for creating the custom electronics. Let's move on. Next, I can show you some of the robot's parameters. We've already mentioned that the robot weighs 75 kilograms and is 1 meter 80 centimeters tall. But what does that mean? It means the robot is big. It has quite a high power-to-weight ratio, and the fact that it's large allows us to install these powerful computers on board. On board, there are 2 powerful GPU computing units and 1 powerful GPU computing unit. 2 powerful GPUs, 1 powerful GPU for computation. I can't disclose the details or the manufacturer, but they are powerful enough for artificial intelligence. There are also about 20 microcontrollers or more. Here, I have to give credit to the team. Alexei Vedernikov, who made this hardware look so beautiful, as you just saw. So let's say we have a robot that's assembled in hardware. What needs to be done next? Actually, even if you've built the robot, it won't just stand there. Any gate, any attempt to stand, or simply standing, it's all a matter of constantly controlled falling. To make this possible, you need to develop algorithms so that it moves well, stands well, and even dances well. And what can I say? Recently, there was a trend towards so-called model-based algorithms based on MPC and other technologies. Now that trend is changing. Now more locomotion technologies are BC, based on learning-based approaches, including on rail. If we look further ahead, we are already in the transition from just real algorithms to foundation models. This is a planned development of algorithms, but now with a much larger capacity of neural networks and a much greater amount of data required for this training. Now I'm going to show you some cool videos, so that no one can say later that we bought a Chinese robot. Look, these are our very first prototypes, which we started testing about 1.5 years ago. This is the first leg with a slightly different kinematics, and the first walking platform, which moves based on optimal control technology. Isn't it cool, though? We kept going, we built the robot's body. The head here honestly isn't very pretty, compare it here and there. But what we did first was test locomotion technologies. And the focus was on model-based approaches on MPC. We worked hard, tried many variations in other settings. But unfortunately, the model-based technologies didn't give us the results we wanted. But we had an ace up our sleeve. At the same time, we were developing reinforcement learning-based technologies. At first, we developed them using small Chebrashka-like robots, and then started transferring them to larger robots. Right now, you can clearly see the innovative recorrecting technology displayed on the screen, and there should definitely be a really cool dance performance accompanied by engaging music. Take a look at this spin. If only you truly knew just how much dedicated effort our entire team, and especially Zhenya Panvarev's incredibly talented team, meticulously put into the intricate process of reward engineering to ultimately achieve such a truly beautiful and perfectly executed spin. There were simply comments on social media saying, "Your robot doesn't walk beautifully." Well, look, does it walk beautifully or not? I think it looks beautiful. Let's move on. Next is a rather boring slide showing the detailed architecture of the overall control systems, which is confidently expected to be fully implemented and operational approximately 2 years from this current point in time. We plan to focus on learning-based approaches. What does that mean? It means that optimal control will most likely not be used in the control system or will only be applied in limited cases, for example, when it is necessary to combine reinforcement learning with optimal control. And in the near future, control systems will remain hierarchical. What does that mean? This means that at the level closer to the hardware, the system will perform inference quickly. The networks will be small, but they will be responsible for movement. At the next level, system number 2 will house the local navigation system, the decision-making system, the planning system, and so on. And the slowest but the smartest, system number 3, is the one responsible for anti-recognition and decision-making. This is the last slide. Now I want to ask the robot to move forward and say the most important thing I wanted to say. And the most important thing, I'm deliberately not going to say it off the cuff. I'll open my notes. The most important thing is that I wanted to thank my colleagues who took part in creating this masterpiece. An absolutely awesome masterpiece. So, as I already mentioned regarding Ivan Borisov, judging by his Alexei Vedernikov's group, Mechanical Engineering, Roman Meshkovich's group, Better Platform, Roman Zhukov's group, Robotics in Your Engineering, Evgeny Ponomarev's group, Rinfos Metronic, Vadim Bolshakov's group, Electronics and Fairway, Stas Kolesnik's group, Sensorica. And I can't help but mention our esteemed EPMs, Sergey, Tatiana, Alexander, and Andrei, who managed this entire development process. And of course, the marketing team, without whom my presentation, the previous presentation, and most importantly, yesterday's presentation would not have been possible. Sorry if I forgot anyone. Guys, thank you all. Maxim.
Maxim! Maxim! Maxim!
Maxim, 1 minute. I forgot the most important thing. I just wrote it down in my previous message. Love Steam Group. These are the people who made with their own hands what you see now. They worked day and night. There were many sleepless nights, a lot of overtime work, and forgive me for the insider info, there were many times the robot fell. And after every fall, the Love Steam team picked the robot back up.